So in this video we're going to balance this equation and then we're going to think about what our results mean in terms of what we would actually see in the lab if we were doing this. So we have hydrogen and oxygen to give water. We can see that the hydrogen looks balanced already. We have 2 hydrogen as a reactant and that's equal to 2 hydrogen as a product. But I have 2 oxygen as a reactant and only 1 oxygen as a product. So I can go ahead and put a coefficient 2 here to scale the oxygen. So I have 2 oxygen on both sides. But the 2 also scales the hydrogen. So to balance the left, I'd have to put a 2 here. So 4 hydrogen on each side, 2 oxygen on each side. So now it's a balanced equation. I know the mole ratio is 2 to 1 to 2. So that's my mole ratio. So I know 2 moles of this, or 2 Avogadros, multiples of this, react for every 1 mole or 1 Avogadros multiple of that. What does this look like? Well, if I were to look over time, if I were to plot concentration, so what do the species do over time? Well, initially at time 0, I don't have any product. I haven't produced it yet. So I don't have any water initially, but I do have hydrogen. So now this does not mean I have twice as much hydrogen. That's not what this means. So for example, this does not mean I need 2 grams of hydrogen and 1 gram of oxygen. It doesn't mean that. It just means for every unit of oxygen, I have to spend 2 units of hydrogen. That's what it means. It's the change, not the absolute value. It's the ratio of change. So let's say I start with an equal amount of hydrogen and oxygen. So let's say, for example, I start off with an initial amount of hydrogen. So let's say that's my hydrogen. And let's say my hydrogen disappears like this as it's consumed. My oxygen, I would lose half as much. So my oxygen would go like this. So basically, I'm looking at the fact that this slope is more shallow than this slope. So if you like, this slope is twice the size of that slope. And the slope is what takes the mole ratio. The slope is what takes the mole ratio, not the absolute value. So again, this would be the hydrogen value. Let's put it here. This would be the oxygen value, which is smaller.